In this video, we'll take a look at drawing Lewis diagrams for molecules when they follow the octet rule, and also expanded octet molecules. Let's take a look. So when you want to draw Lewis diagrams, this method works in both instances, whether the center atom follows the octet rule or whether it has expanded octet. And the first thing you want to do is find the total number of valence electrons. Remember, you can find this by looking at what column they're in on the periodic table and add that number up for each atom in your molecule. Next, you're going to look and see that one of the atoms is usually different than the others, and so the one that is different or isolated, or sometimes we just call it the weirdo, that element goes in the middle. So the one that's different than the others becomes the central atom. You're going to attach all of the other elements to this central atom, and then give all of the outer atoms a full octet of electrons. So this means each of the outer ones will have 8 electrons, unless of course they're hydrogen, and then they'll just have a total of 2. Then you're going to look and compare the amount of electrons in your picture with the amount of electrons in your total, and the extra electrons will be on the central atom. Usually it'll work out that they're pairs. Occasionally, actually very rarely, you'll see a lone one. And typically that's when nitrogen is the central atom, and then you can put that lone electron on nitrogen, but usually they will be in pairs. So let's take a look at NF3, the total number of valence electrons. We know for nitrogen, it's in column 15, so it's going to have 5. Fluorine is in column 17, so we'll have 7. There are 3 fluorines, so we can do it like that, for a total of 26 valence electrons. Now, one of these things is not like the other, so the N is going to become our central atom, and then we're just going to put the fluorines attached to that with a single bond. And then each of those fluorines then is going to follow the octet rule by having 8. So we need 3 pairs of unbonded electrons around each one to bring its total up to 8. So now each of these has 8, 8, 8. So it's pretty easy to see the total number of electrons because we just finished giving all of these an octet on purpose. So it's really just 8 times how many things are attached. So the total in our picture is 24 electrons. We have 26 that we need to include, so there's 2 electrons that need to be applied somewhere, and the last rule tells us that they go on the central atom as a pair. So NF3 will look like this. We do something similar for PF3, PF5, then our total number of valence electrons, P is also in column 15, just like nitrogen was, so it'll have 5. Now each of the fluorines will have 7 like before, but this time there's 5 of them, so 7 times 5 is 35, plus 5 more. We got a total of 40 electrons this time. So we're going to put our phosphorus in the middle. That's the one that's different. We're going to have 5 fluorines this time. Each one of those needs to follow the octet rule according to the next step. And because we have 5 things with 8 electrons, that's 8 times 5, we have 40. And so there aren't any left over, so we don't need any electron pairs on the central atom. There's our Lewis diagram for PF5. Similarly, we could do this for XeF4. The total number of valence electrons being 8 for the xenon because it's in column 18, and then 7 times 4 for the 4 fluorines. So that's 28 and 8. The xenon goes in the middle. And then all the outer atoms follow the octet rule. And so we have 8 times 4, which will be 32. We have 4 more electrons that we need to use up from our total compared to what's in our picture. So they will go on the central atom as pairs. And there's your Lewis diagram for XeF4. Okay, one more example, ClF2 minus. So when your species has a charge, you have to account for this with your total number of valence electrons. So here we have 7 for the chlorine, 7 for each of the fluorines, and because this is a negative, we add one more negative, one more electron to our total. If this were positive, we would remove an electron from the total. So here we have a total of 22 valence electrons. Chlorine is going to go in the middle, fluorine on either side, making the outer follow the octet rule. And then we count how many in our picture. There's 8 and 8 for a total of 16. So we have 6 remaining to be applied, and those go as pairs on the middle atom. So in this case, we need 3 pairs on the central atom. So there's how you do a Lewis diagram, whether it's expanded, octet, or not.